Hello dear students, welcome to YourPedia. This is Chandrasekhar, Faculty of Electrical Engineering at YourPedia. Today in this session I am going to discuss one previous CGPDTM, Controller General of Patents, Designs and Trademarking descriptive paper power systems one question solution. We are going to see elaborately. See, the main motto of this session is how to write a descriptive solution step by step, how to get full marks of any given question in descriptive paper. That is the main motto, and this question I am picking from is power systems 9B, question number 9B. Yeah, it is the number of the question. This paper is 2018 paper, question number 9 in this B bit. It is this question given. Read the question first. See, the basic thing first of all we have to do is first of all we have to read the question carefully. Read it. A 400 volts, yeah, a 400 volts 3-phase 3-wire fed power system power through a feeder to a delta connected load of impedance 174 plus J 225 ohms between phases. Fine. The feeder impedance is 2 plus J 5 ohm per phase. Find the power supplied to the load. He is saying that the supply voltage is 400. See, always if not mentioned, the given voltage is line to line voltage. Now this is 400 volts. This is also 400, right? But the angle is different. 400 at an angle 0, 400 at an angle minus 120, 400 at an angle minus 240. Yeah, these are the angles. Now he is saying that this is a feeder, this is a feeder, this is a feeder. These feeders are feeding this load. This is the load. This is the load. This is feeder. These are the feeder wires. These are the feeder wires. This is feeder. This is feeder. These are the feeder wires. What is supply voltage? 400. That is line voltage, not phase voltage. Now he is asking, what is the power supplied to the load? He is asking. See, feeder is also having some resistance. Some power loss will take place in the feeder. In this feeder also. In this feeder also. The question is, find the power supplied to the load. Find the power supplied to the load. In the examination, definitely you have to redraw the diagram. Definitely you have to redraw the diagram. Okay. So first the given data you have to mention. Yes, this is the given data. Yes, the given, I am writing here, given data. Solution. Yes. V source line to line is equal to 400 volts, is equal to 400 volts. That is the source voltage. Now Z of a feeder, impedance of the feeder given as 2 plus J5 ohm per phase. Yes, I am drawing the diagram again. I told you to redraw. Yes, delta connected load they given. Each phase is having same impedance. Therefore, this is balanced system. Source is balanced. Feeder is also balanced. Feeder impedance is balanced. All three feeders are having same impedance. Feeder impedance is balanced, right? Yeah. Sorry. Yeah. Yes. So this is phase A, this is phase B, this is phase C. This is 2 ohms, this is J5 ohms. This is 2 ohms, this is J5 ohms. This is 2 ohms, this is J5 ohms. J5 ohms. So this is, what is this? 174 plus J225. This is 174 ohm. This is J225 ohms. This is 174 ohms. J225 ohms. This is 174 ohms. This is J225 ohms. Observe clearly. So this is the source 400 volts. This is 400 at an angle of 0 degrees. This voltage is 400 at an angle of minus 120 degrees. This voltage is, yes, 400 at an angle of minus 240 or plus 120 degrees. Very neatly you have to draw this diagram, not roughly, very neatly you have to draw, right? Then the next point you have to write is, as the system is balanced, as the system is balanced. Why the system is balanced? Power supply is balanced, right? And all feeders are having same impedance. Feeder impedance are balanced, or feeder is balanced. Load is anyhow balanced because all three phases of the load is having same impedance. As the system is balanced, three-phase power is equal to, or simply I'll write, power of three phases is equal to 3 times of one phase power. It is valid, it is equally valid for P, Q and S. What is this? P is active power, Q is reactive power, Q is reactive power, S is apparent power. S is apparent power. Now if you observe, the load is in delta connection. For delta connection, somewhat it is difficult for us to apply direct Ohm's law. Why? Because neutral point is not available. I will convert that one into star. Then I get neutral point, I will get current. Once if I have current, I have voltage. Yes, I'll redraw this diagram. Yes, I'll redraw this diagram. Yes. Now convert the delta connected load into star connection or Y connection. Star, or it is also called as Y connection. Converting it is. Yes. Now I will draw the load. Yes. Observe. Resistance, load resistance, load reactance, load resistance, load reactance, load resistance, load reactance, right? See, I got the neutral points. This is neutral, load neutral. See, how much is the impedance? We'll see. There is a formula for that. This is feeder resistance, feeder reactance, feeder resistance, feeder reactance. Yes. This is feeder resistance and feeder reactance. Now, here I have voltage. How much is this voltage? 400, yes, at an angle of 0 degrees. Now, this is phase A, this is phase B, this is phase C. Between two phases, if the voltage is 400 at an angle 0, between, see, phase to neutral, it will be 400 by root 3 only. 400 by root 3. Yes, we have to get that point. This will be, yes, this will be, yeah. This is, means this is the neutral point. This is not physical neutral. This is 400 by root 3 at an angle 0. This is phase voltage. See, the voltage that is measured from between a phase and neutral is called as per phase voltage. If you measure voltage between two phases, it is called as line voltage. 400 by root 3. This is, see, actually I taken here previously, yes, these voltages as source voltage. Yeah, let's go to the question. What is it? A 400 volts, 3 phase 3 wire system. So I'll take my source itself is in star. As I did not mention, I'll take my source itself is in star. Okay, now that is 400 by root 3. This is 400 by root 3 at an angle of minus 120. This is 400 by root 3 at an angle of a plus 120 or minus 240. Both are same. So this is 2, this is J5. This is 2, this is J5. This is 2, this is J5. Now how much is this? If you convert from delta to star, yes, I'll write here. That also you have to write in the examination. Take some impedance. Yes. This is delta connected impedance A, B, C. Let's take. Now its equivalent will be in star like this. yes, in star like this. Yeah, this is see, no, just a minute, observe here, I'm going to get like this, I'm going to get like this, between here there is one impedance, yeah, here there is another impedance, here there is another impedance, this point is A, yes, this point is B, this point is C, but here an hypothetical neutral is possible here. Now let me write the formula. If this is Z1, this is Z2, this is Z3, then I'll call this one as ZA, this one as ZB, this one as ZC. Now ZA is equal to Z1 Z3 by Z1 plus Z2 plus Z3. ZB is these two connected impedances product by total impedance summation, Z1, Z2, Z3 summation. ZB is Z1, Z2 by Z1 plus Z2 plus Z3. Yeah. ZC is Z3, Z2 by Z2 by Z1 plus Z2 plus Z3. Right? So this is. Now based on this, how much we get here? Let's draw the diagram once again. Why we have to draw diagram these many times? We have to show something here, that is feeder impedance and load impedance both are in series once you convert the given delta into star. Yes, I'll show here. Observe carefully. This is phase A feeder. Yes, this is phase B feeder. This is phase C feeder. Right? Now if you come here, yes, yeah, resistance, reactance, resistance, reactance, resistance, reactance, right? Connect it. Yes, this is phase B actually, this is phase C, right? Now if you observe how much we get, first of all, how much we get here, observe carefully. Z1, if Z1 is equal to Z2 is equal to Z3, if Z1 is equal to Z2 is equal to Z3 is equal to Z, yeah, in our question all three impedances are equal, all three phase impedances are equal given in delta. Therefore how much you are going to get? Then ZA is equal to ZB is equal to ZC equal to how much we get? Z square by 3Z, it will be Z by 3, this will be Z by 3, right? Yeah. So Z by 3 means the impedance divided by 3 times you get. So by using calculator I have to calculate how much this is. This is how much? Observe carefully. Yeah, 174 plus J 225. 174 plus J 225 by 3. So this is 174 by 3. How much it is? 174 by 3. This is 58. Yes, this is 225 by 3. 225 divided by 3, this is J75, 58 J75, this is 58, this is J75, this is neutral. Okay, as it is balanced, neutral will be at 0 volts. Now this is 2J5, right? Phase A, phase B, phase C. So this particular point is neutral. The voltage here it is 400 by root 3 at an angle of 0 degrees. I told you in the very starting, as the system is balanced, 3 phase power is equal to 3 times of single phase power. 3 phase power is equal to 3 times of single phase power. Even current also we can get like that only. Once we know one phase data, remaining other phases data we can get. Now the current in this one is IA, the current in this one is IB, the current in this one is IC, right? So this also we have to mention 2, this is J5, this is 2, this is J5, right? Now let's find IA. Once we get IA, we need not to bother about IB and IC. Directly we can write IB and IC. What is the formula for IA? IA is equal to 400 divided by root 3 at an angle of 0 degrees by 2 plus J5 plus 58 plus J75. Yeah, so this 2 ohms, this 58 both are in series, 2 plus 58. Yes, this J5 and J75 both are in series, therefore it is J18. So IA is equal to 400 divided by root 3 by 60 plus J80. Then how much it will be? IA is equal to 400 by root 3 under root of how much it is? 60 square plus 80 square at an angle of tan inverse of imaginary part. How much it is? 80 by 60, right? 80 divided by 60. Now get IA. That is equal to, let me calculate with the help of scientific calculator. Calculator will be allowed. Without calculator, these complex calculations are not possible, right? So 60 into 60 plus 80 into 80, I think it will be 100. Yeah, it is 100 only. Yeah, 100. So 400 by 100 means 4 by root 3. This is 400 by root 3 into 100 at an angle of minus tan inverse of, yes, tan inverse of, just a minute, minus tan inverse of 8 by 6 it is. Let's do this calculation. Once we get IA, we are done. Right? Yeah. So 400 divided by root 3 400 means 4 by root 3 at an angle of minus tan inverse of 8 by 6 is the correct, right? Minus tan inverse of 8 by 6 is the correct, right? Yeah. Now IB is how much? IB will be, IB lags IA by 120, balanced na? Then magnitude will be same, 4 by root 3 at an angle of minus 120 minus tan inverse of 8 by 6. This is the current IB. Then IC also will be, IC is equal to, yes, 4 by root 3 at an angle of minus 240 minus tan inverse of 8 by 6. We got currents. Now the power, directly I will calculate S. S of load I am calculating. Why? Because he asked the power of load, not from source. Why? Because some power is getting lost in the resistance of the feeder. Some reactive power is taken by the reactance of the feeder. We want S load. Okay, so S load is equal to V load into I load conjugate. But I know I load as circuit is in series, yes. So I have this voltage, source voltage, I have this source voltage, but this load voltage I do not have. This is V load. How to get this load voltage? How to get that load voltage? That load voltage is nothing but source voltage minus drop. Right? Yes. Just a minute. Yeah. Source voltage minus drop. So here, observe all of you carefully. We have the current. First of all, V load is equal to V source. How much is phase A voltage? 400 by root 3 at an angle of 0 degrees minus 2 plus J5 into, yes, what is the phase A current? Phase A current is how much? 4 by root 3 at an angle of minus tan inverse of 8 by 6. That will give load voltage. Let me calculate that one with help of calculator. Okay. Now V load of phase A, I'm taking only about phase A. Once I get phase A, that's enough for me. I can get phase B, phase C. Phase B, phase C will be lagging behind A. See, phase B lags behind A by 120. Phase C lags behind B by 120. Right? Yes. Now this is 2 plus J5. Now we got this voltage. This is the total voltage. load voltage. Now you calculate, okay, calculation part I am leaving it to you. Now S load is equal to V load, how much it is? 400 by root 3 at an angle of 0 degrees minus 2 plus J5 into 4 by root 3 at an angle of minus tan inverse of 8 by 6 into I conjugate. What is I of phase A? 4 by root 3 at an angle of minus tan inverse of 8 by 6 whole conjugate. This is S of one phase, single phase. Yeah, S of single phase this is of one phase, not total. Sir, I want for three phase, what to do? S load of 3 phase is equal to 3 times of, I told you, V. What is V? Yes, 400 by root 3 minus 2 plus J5 into 4 by root 3 at an angle of minus tan inverse of 8 by 6. Yes, this is the voltage into current is 4 by root 3 at an angle of plus tan inverse of 8 by 6. You do this calculation, S load of 3 phase, you are going to get some real part and some imaginary part. This you do this calculation, okay? If you calculate that, you are going to get this particular value. So this way, each and everything very clearly we have to write all the formulae from very starting. See, the question given is, yeah, let's go back to the question again. He said find the power supplied to the load. Okay, that's why I calculated voltage of the load. Why we converted this delta to star? In star we get hypothetical neutral point. If I have neutral point, as both the impedances, field impedance and load impedance both are in series, I can do the series combination and I can apply Ohm's law for finding current. I is equal to V by Z, right? But the given voltage, by default always the given voltage is line voltage. Therefore in a balanced system, phase voltage is equal to line voltage divided by root 3. That's why I taken 400 by root 3 at an angle 0, right? Then we got IA. We have a V load. How to get V load? V load is equal to V source minus drop of phase A. Then we got V load. So S is equal to V phase into I phase conjugate. Never you should forget this conjugate. If you forget this conjugate, you get exactly negative answer for Q. Okay? Yeah, I mentioned the formula here. This conjugate is very important, right? So this way we have to write each and every point to obtain full marks in the descriptive paper of CGPDTM. Thank you.